Hi, I'm Rahul, and in this video we are going to learn how to fit a linear model or simple linear regression model using R. And I'm going to use a IPython or Jupyter notebook instead of RStudio because I like the markdown. You can insert some text for your convenience. So here in simple linear regression model we are going to use a real life data set that contains SAT score and a GPS score. So here for simple linear regression is only applicable if you are predicting a continuous variable instead of a discrete or multinomial variable. So here we will try to predict the GPS score based on just SAT score. And here I'm going to use the inbuilt LM method in R, that linear model or LMH function to predict or to fit a simple linear regression. And along with I'm going to use some libraries like the dplyr for data manipulations, or here I'm going to use the glimpse function from that instead of str, and then reader to read the data set from your directory, and ggplot2 for plotting purpose. So I have created a directory where I save this IPython Jupyter notebook file and along with my data set, and you can see now it's showing R in the right top corner. That means the R kernel, I'm using the R kernel for running the R in background. So if you want to see what is in your existing directory or current directory, you can use the dir function. First of all, don't forget to install and import those libraries. So I have imported that library by running that cell, and now I am running that function dir, that is directory. It will show what exists in your current directory or current working directory. So if you see, it contains 3 files, one for simple linear regression using Python 3, simple linear regression using R, and simple linear regression.csv file. That is our data set that contains the 2 variables, SAT score and GPS score. So to read that data, I'm going to use the reader packages from reader package, the read_csv function, and inside that I'm supplying the dataset name .csv extension and saving in data. If you run the cell, it will read the data. If you want to see the first 6 rows, then use the head function. It will show that the SAT and GPA, 2 variables, and both are double, that is numeric. And if you want more details, you can go for the str function. I'm going for the glimpse function from the tidyverse or dplyr package. So if you supply the data inside that function, it will show you that it has observations, 84 observations, 2 variables, and both are double, SAT and GPA. So if you want more details about the mean, max, minimum, maximum, mean, and first quartiles, second quartile, third quartile, then you can directly use the summary function, and inside that supply the data. It will show you the mean, first quartile, median, mean, third quartile, and max for both SAT and GPA. And let's see how the relationship is between these 2 variables actually, whether it's a positive or negative relationship. So here I'm going to use the ggplot2 package. First use the ggplot function, inside that give data equal to data, because we have saved the we have loaded the data into data, and with comma mapping equal to in aesthetic AES, inside that give in x-axis SAT and y-axis GPA, plus as we are plotting a scatter plot, so I'm using the gem_point, and next I'm also using another function theme_classic. It is a classic theme, so it will provide a cleaner plot. So if you press Ctrl Enter, it will plot in x-axis SAT and y-axis GPA, and you can see that the trend is increasing. As the SAT score increases, the GPS score also increases. So let's fit a linear model or simple linear regression model. So to fit a simple linear regression model, use the lm function that comes under the base R inbuilt package stats from stats, you can directly import that, the lm function. Inside that function, first I'm giving the GPA, that is our dependent variable that we are going to predict, and after that tilde sign, that means predicted by SAT score, SAT. So the GPA will be predicted by SAT score with comma data equal to data, and we are saving that model in model 1. If you run that cell, it will fit the model. If you see the summary, that will give you a detailed report of the fitted model that contains the coefficients, different fit statistics like R square. Here I am not going to talk about every details. For that I will create a separate video where I will talk every detail of this such a report. But here I would like to concentrate on this row, that SAT estimates or coefficient. The first row is about intercept, second row is about SAT score coefficient. So how you will interpret that, because we have a linear relationship between SAT score and GPA, we can interpret it like like if 1 unit increase, there is a 1 unit increase in the SAT score, the GPA score is increased by 0.0016557, and it is also significant. And here it is a simple linear regression, so we can directly go for the R square value here, 0.406. For multiple linear regression, we will more concentrate on the adjusted R square. We will talk about it later, and let's see how this such a fitted line such look like. So we can plot that fitted line or regression line using two methods, by manually calculating it or by a inbuilt ggplot2 method or as a function. So here first I'm going to calculate it manually. So y is equal to mx plus c. So it is the simple linear regression case. So here we are calculating the y hat or predicted y values based on mx plus c, that is m is slope, x is the variable values, and plus c or whatever, or sometimes we will say b, that is intercept. So here the slope is 0.0017, you can see 0.0016, I am rounding it to 17, and with multiply from data I am taking the SAT score. The SAT score value will be multiplied with this value or coefficient plus the intercept value 0.275. That will save on inside the y hat or y predicted y values or fitted y values. So in ggplot2, first I am just plotting the points as a scatter plot. So in data equal to data, mapping in aesthetic x is equal to SAT and y is equal to GPA, and geo underscore point and geometry is geo underscore point, color equal to blue, plus in geo underscore line, then I am giving a overlay of the line, where in aesthetic I am giving the same in x-axis SAT score and y-axis now the y hat values or the fitted values, with comma color equal to orange, and theme is classic. If you press Ctrl Enter, it will fit the line over the scatter plot, and you can see the trend. It is increasing in increasing order as the SAT score increases, GPA score also increases. So next we can directly use ggplot2 such inbuilt function. First we are again plotting the scatter plot of the points, then with plus sign I am giving in another function geo underscore smooth, and inside that just you have to provide the method equal to lm or linear model, and here AC equal to false I am giving because I don't want the confidence interval, and with plus theme underscore is a classic, that is a classic theme. So if you press Ctrl Enter, it will automatically in background calculate the fitted values and plot. So now you can see the same plot with geo underscore smooth method equal to lm method by supplying method equal to lm. And if you want the confidence interval, just remove this AC equal to false and press Ctrl Enter. It will show the 95th percentile confidence interval along with the fitted line. So this is the way you can fit a simple linear model. You can also I will in next video I will show the same trick using the Python, how we can fit the simple linear regression using Python, and then I will go for the multiple linear regression. So thanks for watching.